All right, so at this point, we have discussed some of the subtle differences between C and C++. We've seen that the way that we write the programs is similar in terms of structure. You need to have a main function. We'll include libraries in a very similar way, and so forth. Now I'd like to push a little bit further ahead in terms of looking at the differences between the way that we do input and output in C and C++. So to begin with, I have already created this simple kind of skeleton file called hello.u.c, and we'll go ahead and look at it. In this program, all we're going to do is we're going to ask the user for their first name and age, and then we're going to reply to the user using their name and age to say something somewhat sensible. Okay? So if we were doing this in C++, we would almost certainly use a string object to store things like the username. And for the age, we'd probably use an int variable. So I'll go ahead and set this here. Whoops. And we would then use cout to prompt the user and say something along the lines of, please enter your first name followed by your age. And then we'd use the cin object to read that name and the age from standard input. And standard input is generally connected to the keyboard. So we're reading things from the keyboard. We could then reply to the user by using cout, and we'd say something like, hello, pardon me, okay, hello, that is not what I meant, okay, hello, we'll get there, hello username, we'll just put a period then, and a space, and then we will say something about their age, so we'll print the age, user age is a great, I don't need that capitalized, I suppose, is a great age. Okay, so it's a little bit of nonsense here that we're doing, but we're just trying to demonstrate input and output and how to use variables here. Okay, so this won't work in C because several things. We don't have access to the string class, and we don't have access to the cout and cin objects. So we're going to need to modify this to work with with C. So let's start first with the string username. In C, we don't have strings, but we have C strings, and all a C string is an array of char. Okay, so I've now created this array username, and I can store characters in it, right? Now, if we're going to store a string, a C string, in a char array, then that array needs to be at least as large as the string we want to store plus 1. And the reason for the plus 1 is that the way that we will know we've reached the end of a C string is that it will be terminated or ended with the ASCII code 0, or the null character. Okay, so this is kind of like a flag that is used by the various functions and subroutines that we'll use that deal with strings and deal with C strings. They're going to watch for that null character to know that's where they stop in memory when they're dealing with our string. Okay, now you might be thinking about that going, that seems odd and like that would have limitations and vulnerabilities. And you're right, it does. But nevertheless, it is the tool that we are generally going to use in C to store strings. Okay, so I've created this username array, and I've with 256 positions. So hopefully the user doesn't have a name that's bigger than that. But for now, we're not going to take any steps to make sure that their name's not bigger than that, or that we don't try to go too far. We're just going to assume that 256 characters is enough. Okay, now, as was mentioned before, we don't have access to cout, so we've got to do something different here. Now, we've already demonstrated the use of printf. And so for this first line, we can simply change this statement from one involving cout to one that utilizes printf. And this will prompt the user the way that we want. I should mention also there's no problem using an int. That data type is available to us in C, and so we'll leave that alone. Now, here we are with cin. This is something we haven't discussed yet. in order to read input from standard in, the tool we'll usually use is called Scanf. Okay, and I'm actually going to do this for now. So Scanf uses, again, this notion of a formatted string. Now up here, where we were printing out a string, it's just a simple string, but it can be what's known as a formatted string, and we're going to discuss that in just a moment. Actually, we'll discuss it now. A formatted string is just a string that contains some special symbols that indicate the position of a variable in input or output. So to understand this, I'm going to point you to a resource you can use. This is c++.com, and it has a lot of resources that can be used when you're working with C or C++. We see there are articles, tutorials, and so forth. And there's a little search bar here, and so you can search for topics. Again, whether they're C or C++ related, you'll probably find a good answer here. So I'm going to actually just type in Scanf, and you'll see that it brings up essentially a man page for Scanf. Now, if I'm working in C++, instead of including standard.io.h, I could include C Studio, or C standard.io, you might read it as. And I'll have access to these same functions and so forth working in C, or excuse me, working inside of a C++ program. But the information here is the same whether I'm using this in C or in C++. So how does this work? Well, the function returns an int, and then we have the arguments that it takes. Okay, now let's read let's read about what it does. It says here, reads data from standard in and stores them according to the parameter format in the locations pointed by the additional arguments. Yeah, that was clear. Okay, so I'll demonstrate this and it'll make more sense. Now, in order for this to work, we're going to need to know about something called format specifiers. So it says here, a format specifier follows this prototype. We have the percent symbol and then some stuff. So there can be this wildcard, or we can, well, actually, I'm going to leave this out for now. So these are some things we can do to modify the specifier, which will follow at the end. We'll come back and talk about some of these actually in a later video. So here we have the specifier for an integer. So if we're going to read or write, turns out also we use these same format specifiers in printf. If we're going to read or write an integer, we can put a %i. Or if it's a decimal integer, we can put a %d and so forth. So I'll ask you to go and review this table on your own time. And now I'll jump back to our code and kind of demonstrate how this works. Okay, so the way this works is I'm going to provide a formatted string that will have these specifiers in it. So we'll want to put them in the order that we expect to receive them. So I expect to receive first the first name, then followed by the age. So the first thing that I want to read with scanf is going to be a string. So I'll use %s to specify that. Then a space. So we'll separate these with spaces. And then I'll put a %d because I'm going to read a decimal integer. Okay? Now, this string is fed in as one of the arguments to scanf, and scanf will dissect that string and extract these format specifiers. And so it's expecting then it's going to read a string and then a decimal integer. Now what I need to provide it is a place to put them. So I want to list in order the variables that correspond to the different specifiers. So I would like the string to be stored in username. And then I would like the decimal integer to be stored in user age. Now, there's a problem with the way that I have this typed right now, and I'm going to leave that problem for a moment because it's a common mistake that people make, and I want to show you what it looks like when we make that mistake. So for now, I'm going to actually comment out this piece of code that we know won't compile because it includes C++ code. And I'm going to save and try to compile the code that we have. So I'm going to go ahead and write this, and I'll background Vim. Okay, and for now, I'm going to invoke the compiler myself. In a moment, we'll add this simple program to our make file. But for now, let's just go ahead and try this. Okay, now you'll notice we've got this warning. It says format specifies type int star, but the argument has type int. And it's even pointing it to us. So right here, we're specifying we'd like to read a decimal integer, and then here we've provided an integer. Now that it seems like that's what we would want to do, especially because when we tried to read a string, we provided username, which was a char array, so it can store a C string. It was happy. Well, the reason is that we want scanf to actually modify this variable. And you remember that if I just put a variable's name, then it's passed by value in C and in C++. And so the value of user age right now could be being passed into scanf, but scanf would be unable to actually change this variable within the function that is calling scanf. In other words, when scanf returns, user age will not have changed because it was passed by reference. So that's not going to work. Now we don't have this neat passed by reference syntax in C that you're used to from C++, where we could just put an ampersand up there and, in the function definition, we could put an ampersand up there in the argument list, and the compiler would know it needed to generate code that allowed scanf to change user age. We don't have that mechanism available. So how are we going to do this? Well, we're going to use pointers. Okay, and this is part of the reason that username works the way that it does. You'll remember that in C++ you were probably told that arrays are always passed by reference. Well, the reason that that is basically true is because username is an array, and when we use the name of an array, what we get, if we use that name by itself, is the address of the array. If we use the name of a normal variable, let's jump back in and look at some of this. Oh, I've messed up. Let's see here. We want to abort. I want to foreground. There we go. Bam. Okay. So, for instance, if I use the variable name user age anywhere in my code, the compiler is going to generate code that goes to the memory location of user age and pulls out the data. Okay, that's the default behavior. And so that's what's happening here. However, when I use the variable name, the identifier of an array by itself, without anything else, then the default behavior is to return the address of that array, of the first element in the array. So I'm already giving scanf the address of username because it's an array. And that's where we get this arrays are always passed by reference type behavior. Whereas with user age, I'm trying to send it the value. So I need to change this. So if I put in, oh, pardon me. All right, if I go into insert mode and I put in this ampersand in front of user age, this is now saying I want the address. So the compiler will now send the address of user age into scanf, and that's what scanf is expecting. So that's why it gave us that warning. It said, hey, you seem to be wanting to allow me to record an integer, but you didn't give me an address of an integer. Instead, you gave me an integer, or I should say int. Okay. So now we fixed that. So scanf now will write the integer value, the decimal integer value that it reads, to the int user age. All right, enough of that. So if I was to compile it now, that warning would not be there. Now we need to change this last line. Again, we don't have access to cout, so we're going to use now printf, but we're going to use it in a little bit more advanced of a way than we have so far. Instead of just printing a string, we're actually going to use a formatted string. What that means is we're going to use these format specifiers to indicate positions in the string where we'd like to insert the value from a variable. So, hello blank, well, I would like to put the username here. All right, and then I'll follow it by a period. Now look how nice this is. I can just keep typing. I don't have to end my string and put a bunch of these, left pointing chevrons and so forth. I can just keep typing the string. So, hello so-and-so. Let's see, then we want to print their age, so we'll put a %d again. This is the position then in the string where that value will show up. And then I'll finish the sentence, is a great age, exclamation mark, and we'll put a new line. Okay, we're almost done. So now after I've finished the string, the way this will differ from our first printf statement is now I'll put another comma and I'm going to provide more arguments. And these arguments will be the variables in order that will be accessed in order to fill in the locations in this formatted string where I have these format specifiers. So, for instance, I want to replace that %s with the value of username. And I want to replace the %d with the value of user age. Now, in this case, I'm not changing the variables. I just want to read from them. And so that function is not expecting an address now. It's just expecting to get a pass by reference value. So we don't need to use the address there. We do, however, need to use the correct name. Okay. I'll get rid of that last bit of comment. And there we have it. So now we have a program written in C that should read in a string and an int from the user and then print back a message using that information. So let's see if I've done this correctly. So we'll write this out and then I will background it and we will again try to compile and then run. Oh, pardon me. This will be a.out at the moment. Enter your first name followed by your age. Sure enough, my name is Frank and 37 is a great age. Okay, so last thing I want to do now is add this tool, or rather this simple program, to my make file. So I'm actually going to go ahead and close this, and I'll open up my make file. And let's create a new rule for hello you. And this rule requires hello you.c. And I'm going to save myself some time here. I'm going to leave insert mode, and I'm going to use a capital V to visually capture. Here you see visual line. That's what the capital V stands for. So now I've grabbed this line, and now I want to copy it. I'm going to copy it by using Y. Okay, so you can cut it by, if I hit C, it'll copy it and cut it out of the code. I don't want to cut it out. I just want to copy it, so I'll use a Y. And now I can move back down to this line, and I am going to use P to paste at this location. Oh, and actually I should have used a capital P so that it didn't add this extra line here. It put it after the new line. I actually wanted to put it in front of it. So no worries, I'll just go in and delete there. All right, so I need to make a slight modification to this rule. This will be hello you, and this will also be hello you. Okay, so let's save this and make sure our rule works. Okay, appears to work fine. And I want to make a couple more modifications. So at this point, I now have multiple executables that can be generated if I add hello you to this all rule. And so I'm actually going to add another variable here that I'm going to call build targets. So add another variable. And I'm going to list the things that I can build. The reason I'm doing this is I'm going to add another rule to help clean up when I need to. I'll call this rule simply clean. And what I will do is I will remove anything listed in this variable build targets. Okay, so this gives me an easy way to get rid of a bunch of these things if I've built them. So now if I background this, you'll notice I've got, I'm going to remove a.out as well. Okay, so you'll notice right now that hello you has been made. If I simply type make all, then here it's built hello. Hello you is already built. So now if I type make clean, it's going to delete those two things. So you'll see they're not there. So now make all generates both hello and hello you. and make clean gets rid of them. And if I was to type make hello, I would get just hello. Okay, so just demonstrating a little bit more with the make file there and how we can use it. So hopefully this makes it a little bit more clear the kinds of things that we can do with printf and scanf. They're pretty powerful, and they're the default tools we'll use when we're doing just basic text-based input and output with the terminal. In another video, I will talk about using something called fprintf and fscanf, which are more generic and we can use to not only read and write from standard input and standard output, but which we can also use to read and write from and to files.